Good afternoon, everyone. Myself, Devanand Shah. I'm doing my work under the supervision of Dr. Anupam Shah from the Department of Molecular Biology and Biotechnology, Tezpur University, India. So I'm here to present a flash presentation on the topic that is multiple target approach on Leishmania Donovani pathways for essential enzymes. Now, for the introduction, this visual analysis is also known as Kalajar. It's occurred due to Leishmania Donovani, and the different symptoms of it are fever, weight loss, etc. And it is found in different countries like Nepal, Bangladesh, and some of the African countries also. The two proteins which have been selected for our work is adenine phosphorylase transferase, that is APRT, having PTBID, IQB7, and other protein that is dehydrogenase from the different pathways, that is APRT from the purine pathways and DHODase from the purine pathways of Leishmania Donovani. Different astrology inhibitors of the selected proteins have been taken from related species. This is the workflow of my work, in which first of all the selection of target protein, next is the selection of ligands, next the downstream analysis of the work has been put forward. First, the purine pathway and pyrimidine pathway have been selected from the Leishmania Donovani amyloid form. Then APRT and DHODase protein of the specific pathway has been selected. Then the screening of ligands have been done with the help of different filtering parameters, having lipid schedule of 5, ADMET screening, pass analysis, etc. Then further molecular docking has been done with the selected ligands and the two proteins. Then we have gone for the MD simulation of 20 nanoseconds. Then we have gone for the MD simulation of 100 nanoseconds, which further give rise to the MD simulation analysis and MBBC analysis. Next, this is the pass analysis, where we have done with the help of pass online solver, where in table 1 represent the pass analysis of the inhibitors and table 2 represent the pass analysis of the compounds, where the cutoff value of it is 0.5. In both the cases, the compounds which giving high value of the 0.5 have been selected in the table, and the inhibitors are presented on the table 1, which showing different PA value according to their reactivity. Now this is the docking analysis of the DHODase protein and the APRT, where we have used Autodoc version 4.0 software. Table 3 docking analysis for the protein with inhibitors, whereas table 4 represents the analysis of the proteins with the ligands. Here we have the 5 ligands have been selected from the different parameters and the docking analysis, and having the docking score, a good docking score. Now we have done 20 nanosecond simulation for our work for the selection of the ligand from the 5 to for it. Here we have done the ligand with the RG, RMSD, RMSF, where we can see that ligand 2 and ligand 3 showed good considerable stability throughout the simulation in all 3 of the cases, respective with the ligand and the inhibitor of it. Now we have done MD simulation of 20 nanoseconds for the DHODase proteins with the ligand. Here also you can see that in all the cases, that is RG, RMSD, RMSF, where the ligand 2, ligand 3, in all the cases showed a good considerable stability with the ligands. The main motive of this work of doing 20 nanoseconds is to select 2 ligands from the other ligands, and thus ligand 2 and ligand 3 has been selected for our next analysis. Now we have done 100 nanosecond analysis for MD simulation for APRT protein and DHODase protein for the ligands which have been selected. Here you can see that APRT protein control and APRT control in both the cases of RG and RMSD showed a considerable deviation, whereas the inhibitors and the ligand showed a good result. Both ligand 2 and ligand 3 in DHODH, in RG as well as in RMSD showed a considerable good result with respect to control. Here we have shown the RMSF and H-bond plot analysis. Here you can see that H-bond plot analysis of APRT and DHODase with ligand 2 showed a high H-bond number compared to ligand 2 and inhibitor, thus showing the analysis that ligand 3 can be a good potent inhibitor for the anti-Leishmanian activity for the complexes, and thus showing a good stability. Now we have done MABP analysis, where you can see that APRT ligand 3 and DHODase ligand 3 showed a high binding energy irrespective of the other complexes in ligand 2, DHODase ligand 2 and the inhibitor. This is because of the high electrostatic energy present describing in both the cases, in both the complexes, that is APRT ligand 3 and DHODase ligand 3 in both the cases, thus establishing the fact that it showed a good stability and complexes thus can inhibit the protein for further analysis. Next, we have done the part residual decomposition energy analysis, where you can see that two ligands and the inhibitor of the respective protein have been put forward, where you can see that ligand 3 in both the cases showed a high residue contribution for the binding energy. And you can see, irrespective of the other two ligands and the inhibitor, the ligand 3 showed a high binding energy to the protein, thus establishing the fact that it is quite ligand 3 showing a good result for taking the inhibition. Now, in the conclusion, you can say that 5 ligands have been selected from the different filtering parameters with a PRT along the DHATase protein. After 20 nanoseconds, 2 ligands have been selected, which showed a better result compared to other, that is ligand 2 and ligand 3. In inference with the 100 nanosecond MD simulation MBBL analysis, ligand 3 have the potential to have can act as an anti-Leishmania agent for treating VM. For further analysis or further establishment of the ligand 3, in vitro and in vivo experiments are required for further analysis. These are the references which I have used in my work. Thank you. Now I am open for questions.
Thank you. So we have time for questions. The first question from Kunal Roy: what is the significance of radius of gyration in MD simulation results?
So, sir, what, sir?
Do you hear me?
Yeah, I'm hearing. So, what's the question? I'm not getting that.
So the question:
what is the significance of RG? Sir, as the name suggests, radius of gyration, sir, it is the distance from the center of the protein to the outside of the or the periphery of the protein. So the less the distance of the from the center of the towards the outer of the protein, more the stability of the compound. Thus it can say that whenever the RG value is less than compared to the other structure, then that means that the that compound or that complex should have more stability towards that analysis.
Okay, thank you. The next question from Hanok Shenderovich: could you clarify how MD simulations were used to select these 2 ligands?
So as I have said, first we have gone for 20 nanosecond MD simulation, in which there are 5 ligands along with inhibitor, 1 inhibitor of it. So from that that analysis we have selected 2, and further we have gone for 100 nanosecond analysis, where we have gone for 5 analysis in MD simulation, RMSD, RMSF, RG, and H-bond analysis. Further, we have established the thing with MMPs analysis, where you can see that ligand 3 showed a high hydrogen bond energy compared to ligand 2 and the inhibitor, thus showing that the 2 ligands or the ligand 3 showed a good considerable evidences for further inhibition for the protein, respective proteins, 2 proteins.
Okay, thank you. The next question from Kunal Roy: what is MMPBSA?
Molecular mechanics Poisson-Boltzmann's analysis.
Okay. Question from Hanok Shenderovich also: how did you verify that MD simulations indeed converged?
Did converge, sir? I didn't get actually. And so, in what context?
How you verify that your simulations, MD simulations, were converged, that they are stable? How did you do that?
Sir, we can at the end of the MD simulation, we see that from the initial and the final, there is a considered decrease in the. Sir, I will show the be better. So you can see that there is a quite stability in both the cases here, and there is not so much fluctuation in ligand 2 and ligand 3, irrespective of the other proteins or inhibitor. And there is a quite stable throughout the after 75 nanoseconds. There is a quite, as you can see, it is between 0.5 to 0.6, which is very less in case of through fluctuation in last of the simulation process. So from that, we have tried to say that it got a converged. In both the cases, you can see that also in case of RG also, you can see that there is a after 90 seconds, you can see a convergence of the graph.
Okay, thank you. So we can We have time for one more question from Vladimir Sulimov. How do you estimate energy of hydrogen bond contribution to the binding energy you calculated?
Sir, as we can see that we have done the MBBC analysis. MBBC analysis having the higher electrostatic energy. So electrostatic energy having hydrogen bond in it. So from that we can say that the number of hydrogen bond which have been got from the hydrogen bond analysis, that H1 plot is saying a good message to the that part that the electrostatic energy is mainly contributed because of the hydrogen bonding.
Okay, so thank you. Please answer the rest of the question in